Hello everyone, welcome to week 6 of the semester, and as per our week's to-do lists, we'll have a look at the things that we are supposed to do. But before that, I hope that all of you are doing well. I hope that you're keeping yourself safe and sound. So the things that we are supposed to do for this week is, one, we have to attend our lecture class, okay, which is this particular recording at the moment, and also you have to attend your lab-based class as well. Moreover, I hope that you are finishing up your project one, which carries 20% towards your coursework. Your short test one has now been released under my assessment section of the Moodle shell. Okay, so please ensure that you are taking time to attempt those as well. Moreover, your mid-semester exam is in week 7. Okay, so please ensure that you are revising well and preparing yourself very well for the mid-semester exam. Okay, for your short test one, okay, it was released and it has already been closed on Sunday. I hope you have attempted your quiz. Moreover, for mid-semester exam, okay, it will be up this week Sunday, and it will close on week 7 Sunday. So please do ensure that you are revising well for your mid-semester exam. Now, for your guidelines, the mid-semester exam will be tested based on all the topics that we have covered from week 1 till this particular week, week 6. So do go over your lecture notes. Do also go over your lab-based lectures, and also pay a keen concentration on the lab work that we have done so far. In total, you have 20 multiple choice questions or 20 marks. You have 20 marks of short answer questions and 10 marks of true or false questions. Yep, so that's all on the reminders portion. Now for week 6, we'll start looking at our lecture notes. Now on this particular week, what we'll be looking at is, we'll start looking at the topic called animations. Now animations, basically it's more about you having a set of images or a sequence of images, and you're trying to add movement or action into it. Now, not only images, okay, sometimes you have symbols. Using symbols, you may also use sound, combine all these elements and come up with a multimedia that allows you to move objects within the screen. So that is animation. Now, overview, we'll have a look at the introduction of animation. Moreover, we'll look at computer generated animation. We'll look at some file formats used in animation, and also what are some of the things that you need to ensure to successfully create your animations. Animation is defined as an act of making something come alive. Now, in simple terms, it's just a way of adding movement, or it's adding life to something that is still. Okay, for example, you have 2 or 3 images, you combine them and then allow the images to transit or have transitions among the images, so that sort of makes an image. Moreover, if you have a image of a ball, soccer ball, and if you could make it bounce and show it in terms of a series of frames, so that becomes an animation. What are frames? I will be discussing it later in the class. Now, it is concerned with the visual or aesthetic aspect of the project. Visual, something that you see. Aesthetic is some sort of movement. Animation is an object moving across or into or out of the screen, as discussed earlier, something that is moving. In animation, a series of images are rapidly changed to create an illusion of the movement. So you have one image, so you change the stance of the image, and then just by changing or showing the stance of the changes in the images in each and different frames, you're able to show some sort of movement. A very good example here is the diagrams that are shown. So you have one of the images which is pointing towards, let's say if you consider it's like a clock, so it's pointing onto 9, okay, and the other one is pointing somewhere between 10 to 11, and then you have this arrow pointing towards 12, and here between 1 to 2, and then 3, and then between 4 to 5, 6, and between 7 to 8. Now what happens is that each of these represents specific frame. If I would add a timing in between those, so what happens is that the frames would shift within the time frames. Let's say 2 seconds. After 2 seconds, it will shift from here to here to here and moving on. So automatically what it will do is it will show a movement. So moving from 9 somewhere between 10 to 11 to 12 to 1 to 2, 3, between 4 to 5, 6, and between 7 to 8. So that could be shown in form of a animation. So is an illusion of movement. It's not an actual movement. It's just the use of computing technologies or a computer software to show an illusion of movement. Computer generated animation, animation space, and animation techniques. So to actually have computer generated animations, we have something called as animation space and animation techniques. So with the culmination of these two elements, we are able to create an animation. Now, what are these? We'll be looking at in the next few set of slides. Animation techniques, animation process. When you look at the word animation process, it is basically a series of steps that allows you to create animation. A very good example would be is to the use of frames. A frame is basically a single page which has an object at a particular stance. For example, remember the diagram showing at 9 o'clock. So that's one separate frame. And then the next frame would have the very similar image, but in a different stance. That means moving from 9 to between 10 to 11. So those are frames. So to create animation, we have to use a process called as animation process. You have cell animation and computer animation. Now, cell animation is the use of frames, and we also have some other form of animation techniques whereby we are able to move from one frames to another. Computer animation is the way of creating animations with the use of computers. The steps to be followed in creating animation are: organize the execution in a series of logical steps, build an animation tool best suited, choose an animation tool best suited for the job, build and tweak the sequence, post-process the completed animation. Now, first of all, you need to organize your animation frames in a logical order. Meaning, let's go back to the clock example. So if your movement, if our hand is pointing towards 9, so the next frame would be moving between 10 to 11 and then 12, between 1 to 2 and 3. So it would rather seem illogical if I have my first frame showing the hour hand showing at 9, and then the second frame showing at 3, and the third frame showing back at 12, because there will not be a logical order. So in other words, your animation may not look good. So it is always important for you to ensure that when you are organizing your animation, you need to have it in logical steps. Should it not be in logical steps, you may not get the desired outcome or result as you actually wish to do so. And then you have to choose a animation tool. Now, there are plenty of animation tools, but the best one so far that I have experienced, and also that we used to teach in face-to-face mode classes, is Adobe Flash. Now, we aren't able to find a substitute in the online version of Adobe Flash. So therefore, we might not be going over animation-based practicals in the class, but I will definitely provide you with some adequate videos so that just in case in future, when you are sitting in a computer lab in any of FNU campuses, And if you have, now definitely you will have in a computer lab, in a teaching computer lab, you will definitely have Adobe Flash. You may always go and try it out. Third point is build and tweak the sequence. So sequence are those logical steps. Now build and tweak, when you are tweaking means you're altering something or you're changing something. So when you are designing your animation, now definitely you need to have things in a logical step, but sometimes you need to build and tweak the sequence. Why? Probably to add a sort of effect, probably to have something out of the ordinary, have something unique. Okay, so you need to build and tweak the sequences as well. And finally, post-process the completed animation. Now, post-process, once you have done the entire thing, so the post-process would actually include you reviewing the animation and making sure things are set as you had expected, or you are getting the desired result. If you aren't, you can always go in, build and tweak the entire sequence, and then look at the post-process once again. Cell animation. Cell animation is a technique in which a series of progressively different graphics are used on each frame of the movie film. Now, cell animation, remember, we're talking about something called as frame. Now, what happens is that when you're using frames, you're using some sort of graphic. Our clock example, okay? So with each and every cell animation is basically you are progressively showing a graphic and you're putting it in each and every frame in order to create an animation. Okay, so the entire thing is cell animation. The cell is derived from the clear celluloid sheets that we use for drawing each frame. Cell animations begins with keyframes. Okay, don't worry about the second last points, two last points, but do know what cell animation is. Now, keyframes refer to the first and the last frames of an action. The frames in between the keyframes are drawn in the tuning process. Tuning depicts the action that takes place between frames. Tuning is followed by the pencil test. Now, generally in Adobe Flash, as soon as you would create your animation, so you will put up all your frames in a logical order, and then you will follow some form of cell animation. In other words, you will put some form of graphics within each and every frame. Now, your very first frame and your very last frame would be called as keyframes. So what the keyframes do is they will allow the movement to go in a specific order. So the beginning keyframe would say this is the start of that order of animation, and then the finishing keyframe would say, okay, this is the stop. Now, the process where you put a different form or style of animation is called tuning. So what happens in tuning is basically it depicts the action that takes place between each and every keyframes. So from first keyframe to the last keyframe, okay, let's say you have total of 15 frames. So first frame would be your keyframe, and the 15th frame will be another keyframe. So when you add those two keyframes, and then you'll add a process called tuning. Now, how do I add a tuning process? Just a simple button, right-click tuning. So when you add a tuning process, so that allows movement to go or be conducted in a specific style or in a specific order. Now, kinematics is a study of movements and motions of structures that have joints. Inverse kinematics is the process of linking objects and defining the relationship and the limits. Now, kinematics is whereby it's used in animations and used in computer generated animation. Now, generally, let's say you have a triangle. You have drawn a triangle on the screen. Now, for each and every point where your two lines meet, let's say it's a right angle triangle. So you have a 45 degrees within the triangle. Sorry, 90 degrees. It's a right angle triangle. So you have a 90 degrees. So the point where you have the 90 degrees joint and the other two joints, so those would be called as a structure of joints. Now with kinematics, what you could do is you can always go and add some form of effect to those joints, or you can alter or manipulate the joints in one way or the other. Now, inverse kinematics is just a way of showing how these joints are actually linked to the object, and it shows the relationship and the limits. For instance, when you have a right angle triangle, there are certain actions that you could do. Since remember, when you're looking at the triangle, you have 3 points, okay, the 3 joining points. So all those joining points are linked to one another. So once they are linked to one another, you have certain limitations. You cannot rotate the joints to a certain point. Okay, so in that term, inverse kinematics, it shows the process of linking objects, and then it defines the relationship and the limits. And it becomes a bit difficult to explain without actually doing it on the screen or without actually doing it on Adobe Flash. So when I'll be putting up the videos on Adobe Flash, so I'll ensure to include some of these on kinematics and inverse kinematics as well. Morphing. Morphing is an effect in which a still or moving image is transformed into one another. I think we had a look at morphing before as well. Basically, you have a single image or more than one image, and then you try to transform it into something else. It's morphing. The term morphing basically comes up with manipulating one or two different types of objects and forming it into something else. Now, if you look at the picture, so you have a picture of a girl, okay? So the girl's image is been derived to something called as a boy and different variations of it, okay? So that is called as morphing. Now the file formats used in animation, so you have .fla used for .fla and .hwf used in Adobe Flash, and then you have .svg scalable vector graphics files, which are new to HTML5, and they can also be derived from Adobe Flash as well. Making successful animations. So when you want to make successful animations, you need to ensure that you use your animations carefully and sparingly. Why carefully and sparingly? Else you may not get the desired result or output. High quality animations require superior display platforms and hardware, as well as raw computing horsepower. So in order for you to create a good displaying and a proper high quality animation, you need your computer hardware and software to be as such as well. The major focus is specifically on your computer's hard drive and also on the RAM processing capabilities, not forgetting the speed of your processor as well and the size of the processor. Just in case if it's too low, or let's say the RAM is too small, the hard disk space is too little, and your processing speed is also way more less, so you would not be able to produce high quality animations from there. So for you to, in order to create high quality animations, you need to have a good highly spec'd infrastructure, hardware, software, and so forth. File compression is very important when preparing animation files for the web. File compression is just a way of you compressing the file. So why do we compress file? Because we want to ensure that the file size is a bit smaller. Now, why would you want to have smaller file size for the web? So that when somebody is loading up the website on their, let's say if I would go to a particular website, if it takes too long and I see there's an animation or image, so the first thing that will come to my mind is the images and the videos are taking it a lot of time to actually upload it on the web. So very same thing here. If your animation file size is too big, okay, it will take a lot of time to actually load the entire website on the web browser. Likewise, if somebody would like to save the animation file, if the file size is too big, the downloading size would be bigger as well. So these are things that you generally need to consider. If you're just, let's say if your animation file is very large, so just because of this particular animation file size, your entire website may become very, very slow. And people do not want to go and view slow websites. Some common tools that are used in making animations. Okay, I would say the common ones are Adobe's Flash and Autodesk's Maya. So these are the two ones that are most frequently used to create any form of animations. Now, industry standard, in industry, these two are also very much used. Adobe Flash being the most commonly based use because it comes with Adobe Master Collection with CS5 and CS6 versions. And now it's available online with Adobe CC, for which you will actually have to pay a sort of premium for it. So these are some of the snippets from Adobe Flash. So if you look at the rolling ball, so frame 1, frame 2, frame 3, frame 4, frame 5, 6, 7, 8. So as it will be moving, so this will be a first keyframe and this would be a last keyframe. And what you can do is with Adobe Flash, you can do a right click on the bar, the control panel bar. It will give an option for twinning. So as soon as you select twinning and then play it, so you will see the ball rolling. So this is your start point and this is the finishing point where it actually stops. Same thing with the bouncing ball. So your first keyframe here and jumps down. So this is your last keyframe. Now, why this and why not there? Because you'll see there's a point where it jumps off. So start point and it reaches here, you'll have to stop here, and then you'll have another new keyframe and it stops up there. There's another keyframe and it's twinned. Same thing with this, with making a GIF animation. If you would carefully have a look at that. So if you look at the movement of this person and the movement of the dinosaur, you'll see slight changes. First of all, let's have a look at the dinosaur. Probably the legs, you'll see it's moving. So what to indicate is if I would animate this, so this is the starting point and the dinosaur would walk its way to there. So frame 1, frame 2, frame 3, frame 4, frame 5, keyframe, keyframe, likewise for the person. And you can actually edit up here, or you can get the same thing done instead of using it or getting it done outside the image, you can get it done inside the image as well. Now, summary, animation is visual change over time and adds great power to multimedia. Very true. Why great power? Because people, instead of seeing a still image, people prefer to see something moving because it builds the level of understandability. Cell animation uses a series of progressively different graphics on each frame of movie film. Computer animation has eased the process of creating animation. How? Through the use of simple animation softwares. Also, you are able to create animations just by using frames and just by using still images. Many file formats are designed specifically to contain animation, and some of the common file formats that we've looked at is .fla, you have .svg, okay, so the common ones. Finally, the very last slide, your I test myself questions. Please do take time out and try to go over this and see to it that you are able to answer this. You never know, I might test you these in the mid-semester exam. Now, let's go back to the slides and pick on to some important things. This was a very small set of lecture notes, which I'm sure most of you would be happy to see, because small lecture notes simply means less content and easy for you to revise. So first of all, know what is an animation or what animation is. That's important. Also, you should know what are some of the things you need to follow or steps to follow in order to create good animations. Do know the definition for cell animation and tuning. Also, know the difference between kinematics and inverse kinematics. Morphing, we have already discussed about morphing, I think in before last week's lecture. Please do go over it. And the file formats that you use in Flash, especially FLA and SVG, and what are some of the things that you need to follow to successfully create and make animations. So that's all I would like you to note it down and know from this set of lecture notes. Other information, please do read them. They're also important, but do read them just for general knowledge. Now, do know these students for our class was initially supposed to be held on Thursday 2 to 4 p.m. I'm recording the class a day before just because there's a planned EFL power outage in specific areas in Nindi, and same thing with my location as well. So I fall within that planned outage area. Now we had the same thing last week as well. Few days, same thing here is just because we had a big fire incident few distance away from the place where I am living, and just because of that, there were quite a number of damages to the power line. So EFL is sparingly they are trying to replace the power lines on Thursdays and Fridays. So unfortunately, so we have to cancel our classes and then try to ensure that things are up to date. So this is the best that I could come up with in terms of recording the lectures and put it up on the week 6 section of the Moodle show. So instead of you attending the class, you may take time out and relook at this video. I hope that all of you are keeping yourself safe, and also I hope that you're all catching up and attempting your weekly based online quizzes. Now, this is all for week 6. I'll see you all in the lab class. Then, yeah, stay safe. Goodbye, everyone.